So we'll consider one problem based on the different memory allocation methods, that is first fit, best fit and worst fit. So it is all based on we are using multi-programming with variable number of tasks, right? So these are the variable partitions, right? So we have, so on the left hand side we have been given the various partitions that are available, various holes that are available. So this is 100 kilobyte partition, 500 kilobyte partition, 200 kilobyte partition, 300 kilobyte partition and 600 kilobyte partition, right? And these are the processes, right? So first process, it requires 212 kilobytes, 417 kilobytes, 112 kilobytes, 426 kilobytes, right? Now the thing is, we have to allocate memory for these partitions using first fit, best fit and worst fit algorithm, and try to determine whether, so using each of these, whether we are able to allocate memory for all the processes, or is there or is it that we will not be in a position to allocate memory for any of the processes, right? So that we have to see, and also determine what is the wastage of memory, right? So we'll first start with the first fit algorithm. Now the first this process, which requires 200 kilobytes. Here we have 100 kilobyte. So here we cannot accommodate it. So here we have 500 kilobyte. So first fit is the first partition that can accommodate this process. Okay. So we can accommodate it here, right? So it is 100 plus 212. So that means it is 312. So 100 plus 212. So process P1, you can say P2, P3, P4. So P1 is accommodated here, right? Process P1 is accommodated here. So 100 plus 212 is 312. Now we have, this is 500 actually, 500, right? 500. Okay, we'll see that. 100, actually this is 600, this is 800, this is 1100, this is 1700. Okay, because it is a partition of 100, this is a partition of 500, so 100 plus 500 is 600. So the next is a partition of 200, so next is a partition of 300, so 800 plus 300, it is 1100. So 1100 plus 600 is 1700. Okay, so process P1 is accommodated here. Now, so here how much space is available? 600 minus 312. So it is around 600 minus 600 minus 312. 600 minus, actually it is 212. 600 minus 312, right? 312. Right. So it is 8, 2. Okay. So 288, right? So 288 kilobytes of memory is still available, right? 288. So 288 kilobytes of memory is available, right? Now, so the next process P2, it requires 417. Okay. So we start from the first again. So this partition cannot accommodate 417. So this partition, it requires, it is 288. It is not, it cannot accommodate 417. So we leave that. So this partition, it is of 200. It cannot accommodate, right? We leave that. Then the next partition, it is 300 kilobyte partition. It cannot accommodate. Then this partition, it can accommodate 600. Okay. So this process can be accommodated here. So 417 in the sense, so 1100 plus 417, it is 1517, right? So how much of memory is still available here? It is 1700 minus 1517. So it is 3, 8, 6, 1, 0. So here we have 183 still available, right? So this is, assume that here we have accommodated process P2. Process P2 has been accommodated here, right? Okay. Now next we move on. See, here we have this partition, this is free. This partition, it is free, 288. So this partition 200, it is free. So this partition of 300 is free, right? So this partition of 183, it is still free. Now our next process, it requires 112. Again we start from the beginning. 100 partition, it cannot accommodate 112. So the next partition here, it is of 288, right? So 288. So this 280 here we can accommodate that, right? So here we have process P3. So process P3 can be accommodated. It requires 112. So what is the address? Address for that. So 312 plus 112. So it is 4 to 4. So it is 424. Here it is 600, right? 424, right? So here remaining, so it is, it was 288. 288 was the partition, out of which 112 we accommodated. So what is left out? It is 671. Okay. So 176. So 176, it is still available here. 176, it is still available here. Right? Okay. Now the next process. Okay. The next process. So P4, it requires 426. Okay, it requires 426. So this partition, it is of size 100. It is of size 100. We cannot accommodate 426 in it. Okay, this partition, it is of size. We have just now calculated it. It is around one. What is that? This was out of 288. 288, 112. So it is 176. So this partition is of 176. So here also we cannot accommodate. So this partition is of 200. Here also we cannot accommodate. So this partition is of 300. Here also we cannot accommodate. So this partition is of 183. Here also we cannot accommodate. Right? So though the total memory, if you see, what is the, see here we have 100. So here it is what is that, 162, I think, 162. So then here it is 200, here it is 300. So here it is 183. So you have to add all this, right? So what it comes to, it is 5. So 5, what is that, 4, 1 carry, it is 5, 6, 7, 8, 9, right? So it is a 945, right? So though total amount of 945 kilobytes of memory is available, but we are not in a position to accommodate memory for 426. We cannot accommodate. We are not in a position to accommodate memory for this process P4, which requires only 426. So that is, we say it is external fragmentation, right? Though the total memory available is 945, but so that is not contiguously available. That is not contiguously available. So we cannot. We are not. So that means if at all we have 426 bytes of contiguous memory available, then we can accommodate memory for P4. But 426 of kilobytes of memory is not contiguously available. Hence, so we are not in a position to accommodate memory for that. So this is, it suffers from an external fragmentation of this much, right? So calculation, please do it once again. So I'm not sure about this calculation, please. So the same way we can adopt it to, we can apply best fit, right? So for P1, 212, which is the best partition? So that less amount of memory is wasted. So this partition cannot accommodate this partition, this, so okay, so 300 kilobytes. So that is the best possible partition. So here we can accommodate P1, right? So what is the remaining memory here? So 300. So what is the remaining mode? So 100 kilobytes of memory. 100 kilobytes of memory. 212. So that means 212 means 300 minus 112. It is 88, right? 88 kilobytes of memory. It is still there, right? And then for 417, which is the best partition, it is 500, right? So out of 500, we accommodate P2 here. So 500 minus 117, so it is around 83. 83 kilobytes of memory, it is still free. Then for P3, it is 112. 112 where we can accommodate, so in 200. Okay, so 112 can be accommodated here. So P3 I can accommodate here, and out of 200, 112 is used. So 88 it is still available. 88 is still available, right? And then 426. So 426, the best partition is 600. So 600 out of 600. So this is P4. Out of 600, 426 is occupied by P4. What is the remaining? It is, I think it is 174. 174, right? So 174 kilobytes of memory, it is wasted here. So now using best fit, we are in a position to allocate memory for all the processes. Okay, for all the processes we are able to allocate, right? So then what is the wastage of memory? If we calculate, see 100 kilobytes here, 100 plus 83 here, then 88 here, 88 here, then here again 88, here it is 174. So sum it up, it will be definitely less than the first fit case. It will be definitely less than the first fit case, and moreover, we are in a position to accommodate memory for all the processes. Okay, so best fit, it works better, right? Then worst fit is the here the largest partition we have to go for. So 212. So first it has to be the largest partition that can accommodate. So here we have to go for that, right? So the largest partition, right? So P1 is allotted here. So 600 minus 212. So I think it is 388, right? So 388. So this much is free. Then P2 417. So the largest partition that can hold this, so it is 500, right? So here we can accommodate P2, and the wastage here it is 500 minus 417. So it is around 83. It is wasted here. Then 112 can be the largest partition that can hold 112. It is 300. So here P3, right? So 300 minus 300, 1 second, P1, P2, yeah, correct, P1, P2, so 112, so can be put here, so 300 minus 112, it is, I think it is 188, right, 188, okay. So here we have partition of 100, here we have partition of 83, here we have partition of 200, here we have partition of 188, here we have partition of, so I think it is 388, right? But okay, now the next process is 426, right? So 426 of 20 years memory is not available anywhere, right? So that means we are not in a position to accommodate, allocate memory for this P4, so it also fails like first fit, right? So what is the wastage here? So the wastage, if you just calculate, so it is 100 plus 83 plus 200 plus 188 plus 388, so you just sum it up, okay, and definitely it will be more or less equal to your first fit, and also we are not in a position to accommodate memory for one process, that is P4, right? So for this example, so what happens, the best fit algorithm, it works better because we are in a position to accommodate memory for all the processes, and also the fragmentation is less for this case. Okay, so I will pause this video.